This is a pre-lab discussion of a LeChatelier Principle investigation. What you're going to do is look at 4 chemical equilibria, changing concentrations of reactants and products, and changing temperature of an equilibrium mixture. You'll first examine the equilibrium reaction equation and the equilibrium constant expression, which is used for both Q, which is the product of initial numbers, and K, which is the product of equilibrium concentrations or pressures. You'll then make predictions of the outcomes of various stresses applied to these systems, and then you're going to, in the lab, go ahead and impose the stress to verify or deny the hypotheses that you've made. So remember to make a hypothesis before you do a test. The first we will examine is called a common ion effect investigation, and it has a saturated sodium chloride solution, which means you'll have the ions in the water and you may have some solid sodium chloride on the bottom of the test tube. So the NaCl solution is saturated. That means no more ions can be dissolved in the solution. You're going to add concentrated hydrochloric acid. That's hydrogen and chloride ions because it completely breaks up in water. And then there is the equilibrium constant expression. You're going to predict the outcome of adding the concentrated hydrochloric acid. Write it in your book and try to use the argument for K and Q. That is, see what happens to K and see if it's larger than or less than the K. The Q is the product of the actual concentrations, and the K, of course, is the concentration of the equilibrium ingredients multiplied by each other. The second equilibrium you'll study is chromate-dichromate. The chromate ion, CrO4 2-, absorbs light such that solutions look pale yellow. The dichromate absorbs light so that solutions look orange. And you'll need to be very careful because pale yellow and orange are very close to each other. The equilibrium equation is given here, and I've put the colors that are associated with each. There is the equilibrium constant expression. What you will first do is add hydrochloric acid to increase the hydrogen ions and the chloride ion concentration. You'll predict the outcome of that. Then you'll return to the original equilibrium and you'll add sodium hydroxide. And you need to ask, will either ion that's present in the equilibrium react with any of the ions in the equation that you see there? So you'll have sodium ions and hydroxide ions, and you want to know, will either one react with the equilibrium ions that you see on the screen? And then predict, of course, what you think will happen to the equilibrium. And this, of course, is the equilibrium for water. Then you will examine the cobalt-2 chloride complex equilibrium, which we've shown you there. You've probably seen it in lecture. Cobalt ions complex with 6 waters or with 4 chlorides, forming ions. The forward reaction you see up on the screen, where the hexahydrate is reacting with chloride ions to form the cobalt chloride complex in water, that is endothermic. So delta H for this reaction, left to right, is positive. Initially, you're going to start with the salt dissolved in pure ethanol. Well, it's 95%, but it's the other thing in there is methanol, so it's denatured. So you're going to predict, once you have that ethanol salt mixture, what will happen if you add concentrated hydrochloric acid. Then you'll predict what will happen when you add water. What you're predicting is what color will show. And then predict what will happen if you heat the mixture and then predict what will happen when you cool the mixture. Your conclusion. Finally, you're going to make a general inference about equilibrium systems under stress of changing concentrations and changing temperatures, and compare what you have concluded with LeChatelier's principle. Remember at all times to compare Q, which uses the concentrations that you have stressed, increased or decreased concentrations or temperatures. Compare that with K, which of course is the equilibrium concentrations in the equilibrium constant expression.